Okay, this is the second part of section 2.5. We're dealing with transformations of functions. So in the first part we talked about shifting the graphs vertically, shifting our graph horizontally. We talked about reflecting across the x-axis, reflecting across the y-axis. We talked about stretching and shrinking our graph vertically and stretching and shrinking our graph horizontally. And we're going to get into some exercises here that make us use all of these ideas. But before we get into the exercises, I just want to ask you something. I just want you to think about something here for a second. And what I want you to think about is, let me ask the question, does the order of the transformation, does the order of transformations matter? So for instance, what I mean by that is, for instance, should I reflect first, and then shift, or shift first then reflect? Does it matter? And well, it's a kind of, there is no clear answer here, because some of it has to do with the parent function. If the parent function happens to be very symmetric, then the order in which we do the transformations may not matter. But if the function is not symmetric, it could actually matter. It could be the case that if you shift first and then you reflect, that gives you a different graph than if you first reflect and then you shift. Yeah. So let's agree to the following kind of rules. So let's so which transformations go first, or which transformations go last? What do I do first? So I'm going to say order of transformations. And again, this is not a rule set in stone. Sometimes it doesn't matter, but this is just sort of a guideline. Think of it as just a general kind of guideline. So order of transformations. All right, so I'm going to say first, the first things you should probably pay attention to and perform would be the stretch and shrink. So stretch / shrink. And horizontally, vertically or horizontally, order doesn't matter. Vertically or horizontally, order doesn't matter. By order doesn't matter, I mean it doesn't matter if, for instance, if you have both a vertical and a horizontal reflection, it doesn't matter which one you do first. But if you have a vertical and horizontal shrink, it doesn't matter which one you do first. Vertical or horizontal, it should not matter. Order does not matter. The second transformation to pay attention to should be reflections. Vertically or horizontally. And the order does not matter. Okay, and the last thing to sort of pay attention to or perform would be the shifts. Shifts. Vertical or horizontal. And again, order does not matter. What I mean by order does not matter is imagine that you had a function that has been shifted vertically and horizontally. That's when it doesn't matter which one you do first. You can do first the horizontal, then the vertical. That's when order doesn't matter. Okay, so again, sometimes this is actually, this doesn't apply, but keep this idea in mind. Does the order of my transformations matter? Depending on the parent function, it may not, but if it does, then usually do the stretch and shrinking first, and then take care of any reflections, and then at the end do shifts. Yeah, just to kind of keep it on the safe side. So keep that order sort of in mind. All right, now let's get into this exercises that we were given here. All right, so we were given functions. We are supposed to name the parent function and graph it, describe the transformations, and graph the function without a calculator. Okay, I'll give you the opportunity to try this on your own. Pause the video, sketch the parent function, sketch the transformation, and also in the margin here, if you can sort of state the, actually here at the function, you could kind of circle and say what each thing is doing to the parent function. Okay, so hopefully you have at least the graphs of the parent functions and the graphs of the transformations that you worked out, and let's compare answers. Okay, so in this exercise here, f of x, my parent function is, the parent function here is going to be y equals cubic root of x. Okay, I know that that looks something like this. That's what the cubic root of x looks like. All right, so I know my parent function. Now, I'm going to sort of get a little crowded here. I'm just going to, so I'm going to describe the transformations. So this negative right there, what type of a transformation is that negative? So it's a negative, it's outside of my function. You might want to go back to the previous, when we had some rules. So with reflections, if the negative is outside, that's a reflection across the x-axis. So right now, this is a reflection on the x-axis, across x-axis. So let me kind of write it down here. This is a reflection on x-axis. Okay, that's what that negative is doing. Now this minus 3, what is this minus 3 doing? Do you agree that that minus 3 is moving my graph 3 units to the right? Three units to the right. Yeah, that's what that minus 3 is doing. What is this minus 2 over here doing? Well, this is bringing down my graph 2 units down. And those are the three transformations that I see. So I start with my parent function, which is the cubic root of x. I know what its graph looks like. And then I have to do a reflection on the x-axis, and then I have to shift 3 units to the right and 2 units down. That's what I have to do. And this is where you might want to start thinking about, does the order of these transformations matter? Should I do first the shifting and then the reflection? Or should I do the reflection and then the shifting? And again, I gave you a little guideline over here on the right hand side. I'm sorry, it's kind of messy, but we said that the first thing to take care of is stretching and shrinking, then reflections, and then shifting. So right now, according to those guidelines, then the first thing I'm going to do is take care of the reflection on the x-axis, and then I'll do the shifting. And I have two types of shifts, a vertical one and a horizontal one. The order doesn't matter of which one you do there. But I'm going to do the reflection across the x-axis first. So this was my parent function. and then you have to envision reflecting this on the x-axis. So let me kind of do it right here. I'll do it just right here on the margin. So reflected on the x-axis, so negative cubic root of x. So that's the reflection on the x-axis. Well, that would look something like this. Sorry, that's an ugly little sketch, but you get the idea. Because think about reflecting this on the x-axis. This bottom branch goes to the top of the x-axis. This upper branch goes to the bottom. Yeah, so it would look something like this. And so this is what this is first the reflection on the x-axis right here. And then I have to shift this reflection on the x-axis 3 units to the right and 2 units down. So originally I have this little point here at the origin. I still have the point at the origin with the reflection on the x-axis, but now that point that's at the origin moves to the coordinates 3, negative 2. So 1, 2, 3, negative 2. That puts me right there. And I'm not going to be very precise here because it's kind of hard, and it's also difficult with the stylus to kind of make it vary, but you know, my graph sort of does something like that. Yeah. So we started with the parent function, which was the cubic root of x. We said that it's a good idea to first take care of reflections before we do shifting. And then, so we reflected on the x-axis. The reflection on the x-axis looks like that. And then we move this little graph 3 units to the right and 2 units down. And so this little point that was sort of at the origin, where the little bend on my graph is now at the coordinates 3, negative 2. So hopefully, I know that this is a horrible little sketch, but you get the idea. Yeah. Okay, let's think about the next one. So the parent function is definitely the absolute value of x. This 2 right here, we gotta think about what does that 2 do? So if the number is outside, of my function, so like this, like I have a times f of x, we're dealing with a vertical stretch. And it's a vertical stretch if the number is bigger than 1. And it's a vertical compression if the number is less than 1. So this is a vertical stretch. It's a vertical stretch by 2. And then this minus 5, that's shift down. So this is down 5 units. Yeah. So let's see. Let's sketch our parent function. Our parent function looks something like that. You get the idea? I need to start using a ruler. My lines are so wiggly. So that is the parent function. And then what we did to this is we stretched it vertically. So now it's going to be a little bit skinnier. And remember, so we have a vertical stretch and a vertical shift. But we said that we should apply stretches before we do shift. So first do stretching or shrinking, then any reflections, and then shifts. So I'm going to do the vertical stretch. It's going to be difficult to notice the vertical stretch. What the vertical stretch is going to do is that it's going to make it a little bit skinnier. Yeah. So if you thought about the function y equals 2 absolute value of x, it looks very similar to just absolute value of x. It's just a little bit skinnier. Yeah. Originally in the absolute value of x, I had the point 1, 1. Well, in 2 absolute value of x, I should have the point 1, 2. It's a little bit thinner. Okay, and then not only that, but then I brought that, then I shifted that graph 5 units down. So there's this little pointy, there's the little point that the graph has. That point is called the cusp, C-U-S-P. So the cusp gets brought down 5 units. So now we have it at negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. So right there. And now one value gives me 2 here. And I'll do my best here. I'll just, let's see if we can make this somewhat, so something like that. It's a little bit thinner. It's a little bit thinner than the original one, although that's sometimes kind of hard to tell. That's what the 2 did. It stretched it vertically. That's why it's a little bit skinnier looking. And then we brought it down 5 units. So the cusp, which originally was at the origin, now is at 0, negative 5. So let me just label some points here. This should have been 3, and this is negative 2, and over here we have negative 5. Okay, so hopefully these ideas are okay. Remember, if you have many transformations happening, try to stick to this guideline. First do any stretch or shrinking, then do any reflections, and then do any shifts. Alright, let's move on. Next example. Similar idea. We want to just graph without a calculator the transformations. We want to state the transformations, and we want to graph the thing without a calculator. So I'll definitely give you here the opportunity to try this on your own. Pause the video, try to come up with these 2 graphs of the transformations, and then let's compare answers. Okay, let's see. So parent function here, my parent function is y equals x squared. That's my parabola. That's kind of, well, you get the idea. Sorry about the ugly little wiggly lines. Let me identify the transformations. And this particular one is sort of tricky here. This one is tricky. Look, I'm gonna do something here. This one is a little tricky. I'm going to say, so I have negative x plus 8 squared plus 1. Yeah? You see there's a negative that's affecting my x, and I recognize that as a reflection on the y-axis. But I guess just as a guideline, anytime that you have any number in front of your x, get in the habit of factoring it out. So look, right now I have a negative 1 in front of my x. And so then I'm going to try to factor out a negative from everything that's inside of this parentheses. And you'll see why here in a second. So notice what I did there. So I have these 2 terms inside the parentheses, negative x and positive 8. And from both of them, I factor out a negative 1. Why? Because I want to just end up with x. Yeah? And so then I factor out a negative 1. And so then that means, so this x becomes positive, the 8 became negative. And now you see this is a better way of, this is the better way of looking at the transformations here. So this negative right there, let me write it here in black. So this negative, oops, let me see. I want to use black ink just to not crowd everything and make things sort of separate here. Let's see, can I circle that now? Oh, come on. There we go. So this is a reflection. So reflection on the y-axis. That's what that negative does. Yeah? This minus 8, it's a shift 8 units, in this case is to the right, and this plus 1 is shift up 1 unit. So shift 1 unit up. Be careful, so if you had not factored out the negative, if you did not factor out that negative from these two terms inside the parentheses, you might have been tempted to say that there was a shift 8 units to the left because it's plus 8, and you would have said, oh, my graph was shifted 8 units to the left. That would have been a big mistake. You would have gotten this problem incorrect in an exam, or so anytime that you have a number in front of your x, in this case I had a negative 1, you have to factor it out. Yeah, so I had to factor out the negative. So I factored out the negative, I opened up parentheses, it became x minus 8, and now that's how I recognize that the minus 8 is actually in the opposite way. It's 8 units right. Yeah, so let's just look ahead here for a second. You see there's a 3 right here in front of this next example. You're going to have to factor out that 3 from both terms in the parentheses in order to discover the horizontal shifting and see what's going on. Okay, so I have three transformations. I have a reflection on the y-axis, I have a shift 8 units to the right, and I have a shift 1 unit up. Okay, so let me apply them. Let me make my transformations, and remember, we want to take care of reflections first. Well, I'm looking at my parent function. If I reflect my parent function on the y-axis, I'm not going to see any change. It's going to look identical. So, okay, so that's convenient. So then let me just shift it 8 units to the right and 1 unit up. So 8 units to the right, it's somewhere over here, 1 unit up. Okay. So 8 units to the right, 1 unit up. Now when I want red ink, my computer produces black ink. That's just the story of how these things go. Come on, do red. Sorry, technical difficulties. What we're going to end up with is pretty much this little parabola. It's just that it's been shifted 8 units to the right and 1 unit up. But let me see if I can make that happen. Okay, so that is what's going on. This is the point, this is 8, and this is 1 right here. So hopefully we are on the same page here. Let's try the second one. Let's try the second transformation. Let's begin with the easy parts. What's the parent function here? The parent function is y equals x to the third. Okay, perfect. I know what that looks like. That is a cubic, and it kind of does something like this. And it's approximately something like that. Okay, so that's my parent function. And then we said that anytime that you have any number in front of your x, anything like, for instance, in this case a 3, I gotta factor out that 3 from everything inside the parentheses, or everything inside the square root, or everything inside the absolute value. I have to factor out the coefficient of x. So let me do that. So in this case, I'm going to have 1/2, then times 3, because I factor out a 3. So then this becomes x minus 3, and this to the third power, plus 5. So notice what I did there. I factored out the 3 from both of these two terms. And now let me start thinking about the transformations. So what does this 1/2 do? Turns out that that is a vertical shrink. It's a vertical shrink by 1/2. Okay, what does this 3 do to my graph? Turns out that since this number is larger than 1, the 3 is a horizontal shrink. Horizontal shrink by 3. Okay, what does this minus 3 do? The minus 3, what it does is it's a shift. This is a shift 3 units to the right. That's what that minus 3 does. What does this plus 5 do? This is shift 5 units up. So we have 4 transformations, two shrinks and some shifts, and 2 shifts. So 2 shrinks and 2 shifts. Okay. The thing to kind of again keep in mind here is that we factored out this 3 right here from these 2 terms. So we had to factor out this 3 from these 2 terms in order to actually get the correct transformations. So be careful with that. Good. So let's see if we can make a sketch of this this transformation. So let's see. We said that we want to take care of the shrinks before we do any shifting. So imagine this graph, and it's vertically shrunk by 1/2, and then I shrink it by 3, so it's gonna get very skinny. That's what's gonna end up happening. So originally I had x cubed, which looks like this, and now this vertical shrinks are just gonna make it well, the vertical shrink is going to kind of make it a little bit more squat, but then this horizontal shrink is gonna make it definitely thin. So it's kind of hard to see. That's going to sort of be difficult to see. We're gonna be shifting the graph 3 units to the right, 3 units to the right, and then we're also going to be shifting 5 units up. So let me think about that. So 3 units to the right, 5 units up. So that's right there. So originally I had this point which was right at the origin. Well, I moved it 3 units to the right, 5 units up, and my graph is now way kind of skinnier. Yeah, now it's a little bit skinnier, so I don't know, I'm gonna kind of maybe do something like that. Yeah, I know that it's hard to see the vertical shrink and the horizontal shrink, but you know, you get the idea. They're supposed to be there. It's supposed to be skinnier than the original one. So be careful with these types of, whenever you're trying to identify the transformations, if you have a value in front of your x, like in this case we had a -1, in this case we had a 3, we need to factor it out from everything inside the parentheses, inside the absolute value, inside the square root, whatever it may be. Okay, let's move on. Let's try this next little example here. You were given a parent function, which is y equals the square root of x, or y equals the absolute value of x. They told you some reflections, and now you gotta come up with a new equation, with the equation that corresponds to the transformations that were given to you. So pause the video and come up with these 2 equations that we need here, these 2 new functions. Alright, so hopefully you have some functions written down. Let's just compare our answers. So let's see. I need to come up with a new function. So let me say f of x in this case, and it's the parent function is the square root of x, but we reflect it across the y-axis. Then we shifted left 2 units, and then down 1 unit. So I'm gonna write down what I think should be the correct answer. So I should have a negative inside my square root because that's the reflection across the y-axis. And then that negative, now I need to be shifting left to the left 2 units. So I'm gonna open a parenthesis inside here, and I'm gonna say x plus 2. As you see, this, the x plus 2 is 2 units to the left. And then outside of the square root, I'm going to say minus 1. Yeah, and this is correct right here. Now you could, if you want to, distribute the negative in here. That would say negative x minus 2. But if you did this, let's say you ended up with this negative x plus 2 minus 1, that's incorrect. That's incorrect right there, because remember, you have to factor out any number that's in front of your x. Well, in this case, negative 1. If I did that, then that would become negative x minus 2. And well, then this negative is a reflection on the y-axis, but x minus 2 is shifting my graph to the right, and that's not correct. We want to shift our graph to the left. So we don't want this. Yeah, the correct thing is what's over here on the left. Let me just I just want to kind of make sure that you didn't go down this path. Let me just erase this and kind of say that this is incorrect. All right, next one. So I started with the absolute value of x. So I'm gonna call this other function g of x, and it's shifted to the right 2 units and up 6 units. That, I think this is a little bit easier. So I have the absolute value, so shifted to the right, that's going to say x minus 2, and then plus 6. So 2 units to the right, up 6 units. Okay, so hopefully you agree with this, and you get the idea of what's going on here. Last exercise in this section. This one's going to be tedious because we're going to have to sketch kind of a messy little thing here, but that's okay. We'll see what happens. So they gave us the original function. This is f of x. It's this little kind of geometric looking graph here. They gave us a lot of points on it, and what we want to do is graph some we're going to make a couple of transformations. So this is our parent function. We have 2 transformations of our parent function, and we want to sketch the transformations. So pause the video and see if you can come up with these sketches on your own. All right, let's see. So let me sketch A, the transformation A. So let me just first think about the transformations that happen. So that right there, that is 1 unit to the left. This is 3 units down. Okay, so those are the 2 transformations that happen in this new function. I moved my original graph 1 unit to the left and 3 units down. Okay, so then let me sort of track all of the points that they label for me. 1, 2, 3, 4, 5, 6 points. I'm just going to track those 6 points with my transformation, and then I'll try to sketch the graph that happened here. So let's see. Think about this point originally. It was negative 4, 0. Imagine that you move that point negative 4, 0, 1 unit to the left and 3 units down. Where is it going to go to? So I'm moving this point 1 unit to the left and 3 units down. Well, that should be now at negative 5, negative 3. So let me put it down in here on my graph. 2, 4, 5, 1, 2, 3. So negative 5, negative 3, that's this that's this negative 4, 0. Let me label it. Negative 5, negative 3. All right, where does this point go? Negative 3, negative 2. And remember, you had to go 1 unit left and 3 units down. So I think its new coordinates should be negative 4 comma negative 5. So negative 4 comma negative 5. So I think that puts it right there. That is now negative 4 comma negative 5. Okay, let's think about this point right here. This used to be negative 1 comma negative 2. If I move it 1 unit left and 3 units down, then that point should go to negative 2 comma negative 5. So negative 2 comma negative 5. Okay, so that's right there. Let me label it negative 2 comma negative 5. Right now it's this little point right here. 0 comma 0. Where did 0 comma 0 go to? I guess it went to left 1, down 3. So it goes to negative 1 comma 3. Negative 1 comma 3. That's right there. So that point right there, negative 1 comma 3. Okay. Let's see. This point right here, 2 comma 3. Remember, I have to move it 1 unit left, 3 units down. So it should go to 1 comma 0. So right there. That point is now 1 comma 0. Finally, this one, I have to move it 1 unit to the left, so that takes it to 4, and 3 units down, so 4 comma negative 3. Okay, and now let me sort of connect the dots here. Ooh, that was a very squiggly line. Sorry, but it's supposed to just be a straight line. And that is my transformation. That is my transformation. All right, so let's see. Let's think about the next one then. Let's think about the next one. So let's first identify the transformations that are happening here. This negative is definitely a reflection. It's a reflection on the x-axis. And then the 2 is a vertical stretch. Okay, so let's see if we can keep those two things in mind. So I'm dealing with a reflection on the x-axis and a vertical stretch by 2. And so then here it could get a little complicated, because I mean, if we didn't know any better, which one do we do first? Should we do first the stretching and then the reflection, or should I do first the reflection and then the stretching? So we had that little guideline that said that let's take care of the stretching first, stretch and shrinking first, and then reflections. So let's see. Things have been stretched vertically. So my graph has been stretched vertically. So let's see if we can kind of, so this point, negative 4 comma 0. This one's going to be messy, because we first have to take care of the vertical stretching, and then once we take care of the vertical stretching, then we have to reflect everything on the x-axis. So I'm actually going to do it in 2 steps. I'm gonna first do vertical stretch, the vertical stretch part, and then I'll do the reflection. So let me just kind of draw some axes here. Okay, so let me think about this point, negative 4 comma 0. Since it got stretched vertically, now that point should be negative 4 comma 2. Yeah, so I should be at negative 4 comma 2. This other point should be negative 3 comma negative 4. So let's see, I'm gonna try to sketch it. So now I have, I'm gonna say negative 4 comma 2. 4 comma 2 because it got stretched vertically by 2. Now this point right here, which was originally negative 3 comma negative 2, well, now it should be at where? It should be at negative 3 comma negative 4. So negative 3 comma negative 4, let me try to label it down here. Negative 3 comma negative 4. And then this point right here, negative 1 comma negative 2, now should be negative 1 comma negative 4. Okay, and then this point 0 comma 0, it's still going to be there. It's still actually going to be 0 comma 0. It's not going to be 0 comma 4 because that would have been a vertical translation. So that point's still gonna be there. So that one's kind of strange. That one's still just gonna be 0 comma 0. Now instead of having 2 comma 3, I should have 2 comma. Let's see. Hang on. We might be. I'm making a mistake here. So a vertical stretch. Let's see. What does my vertical stretch do? So you multiply your y value by the factor a. So we're supposed to just multiply our y value by the factor a. Alright. So let's see. Let's go back to our example. Sorry. There we go. So I'm supposed to, in order to take care of the vertical stretch by 2, I gotta multiply my y value by 2. So let's see. Let me kind of then, I need to kind of go back here. I made some mistakes here. I'm sorry. So let's begin again. So first let's take care of this vertical stretch by 2. Okay. Actually, no, there was not much wrong here. So let's see. So the x remains the same. What changes is the y value because we're vertically stretching by 2. You multiply the y coordinate by 2. So in this case, I'm going to have negative 4, and then my y coordinate should be 0 times 2. Well, that's still going to be 0. So that point right there then is negative 4, 0 still. And then this next point, negative 3 comma negative 2. Since we stretch vertically by 2, I multiply the y coordinate by 2. So now I'm going to have negative 3 comma negative 4. Okay, good. So negative 3 comma negative 4. So negative 3 comma negative 4. We'll close that parentheses. Okay, this point right here, the x is the same. It's the y that gets multiplied by 2. So negative 1 comma negative 4. So that's good. This point right here, the x remains the same. The y gets multiplied by 2. That's why it stays 0 comma 0. And then this point right here, now it's going to be the x is the same, 2. The y gets multiplied by 2. So that's 2 comma 6. Let's say that it's all the way up here. 2 comma 6. 2 comma 6. And then finally, my last point, the x stays the same, the y gets multiplied by 2. Well, that's still then going to be 5 comma 0 then. So hopefully you agree on how I got these points. All I did was multiply the y coordinate by 2. So 0 times 2 is 0, and well then negative 2 times 2 is negative 4, etc. So this is what my graph looks like. If I stretch it by vertically by 2, this is sort of what my graph looks like. And now the last thing I gotta do is reflect this whole thing on the x-axis. So to reflect on the x-axis, that means that I'm gonna have to change the signs. Well, I mean, if it's a point on the x-axis, it stays on the x-axis. But if it's a point below the x-axis, it should go above the x-axis. If it's above the x-axis, it should go below the x-axis. That's what it means to reflect on the x-axis. So I'm going to have the point negative 4, 0, still the same point. So that point is still negative 4, 0. So here I am in this little sketch. This was 1. Here we're taking care of the vertical stretch. Now 2, I'm going to do the reflection on x-axis. Alright, so this point, negative 4, 0. So think about, I am following an order right now. We had 2 transformations. We had a reflection on the x-axis and we had a vertical stretch by 2. The first transformation that I did was the vertical stretch by 2. I multiplied all my y coordinates by 2, stretch my graph out, and now I'm going to, looking at that graph of the stretch, I'm going to reflect on the x-axis. Okay, so this point is already on the x-axis, negative 4, 0, so it doesn't get reflected, it just stays there. But now this other point, negative 3, negative 4, now that point is going to become negative 3, positive 4. So negative 3, positive 4. That's right there. So this is negative 4, 0. And now I have the point negative 3, 4. And then this point right here, since it's reflected on the x-axis, the x-coordinate stays the same, it's just that it becomes positive 4. So 1, 4. Sorry, negative 1, 4. And then, well, 0, 0, that stays there because that's just the origin. And if we reflect it on the x-axis, well, it stays put. And then this other point that we had at 2, 6, now I'm going to have 2, negative 6. So 2, negative 6, that's down here. And finally 5, 0, that point is on the x-axis. So it stays on the x-axis. And I think that's my graph. I think that is my graph. That is the final transformation. So let's see if we can just put it all together. So there, and then there, and then this goes down all the way to down here and back up here. Yeah, so this one was a little tedious. I first had to take care of this vertical stretch by 2 and then reflect that on the x-axis. Okay, so that is it for these transformations. Practice makes perfect, so go ahead and practice it by doing your homework. Okay, thank you. See you in the next section.